Well, I'm back. Now we're going to test claims about the mean. And in this section, you're going to see that there isn't really much to lecture about because now that we have hypothesis testing down, it's just a matter of doing more examples. So there is this one special case when you're testing the claim about the mean that sigma is known. In other words, you know the standard deviation for the whole population. In that case, you're allowed to use the z for the test statistic. Okay, so that was the lecture. Now, the examples. Okay, so 97% level of confidence. Test the claim the GPA at Hartnell College is 2.8 on average. So the sigma is 0.48. And here's some sample data. This actually comes from one of my students' projects. They interviewed 40 people. They found the GPA average to be 2.98. So test the claim that it is equal to 2.8. So H1 has not equals. It's going to be a two-tailed test. And then for some strange reason, I decided to use 97% level of confidence. So alpha equals 0.03. Okay. Here's the sample data. I always like to write that down. And then here's the picture. It's two tails. If you take 0.03 or 3%, cut it in half, that's 1.5% on each side. So if you look at the table, you will find that 0.015, I was looking at the A2, the negative z table, then you'll find out that 0.015 is right there in the table. So then, if you look to the side and up, you'll find out that's when z equals negative 2.17, and then positive 2.17 on the other side. So there's the critical regions. Next, we're going to use the calculator, and like I said in the lecture part, you know these two sentences right here? We're going to be using z, so it's going to be the z-test. So type in the data. 2.8 is coming from the claim. 0.48 is the standard deviation. It should be not equals so that the calculator knows it's a two-tailed test. That way it gets the p-value correct. And then look at this. Our test statistic turns out to be a 2.37. And a 2.37 is definitely going to go past this 2.17, so that means we actually did prove something. First of all, we say reject h sub o, but then we're saying reject to this equal sign. The claim said the same thing, so the claim is false. So whoever it was that claimed the GPA is 2.8, they're wrong. It's actually higher, a little bit closer to 3 than it is 2.8. All right, then for the second example of the section. And then that's it, we're going home early. Does going to college pay off? Well, I sure hope so, because I've been in college about 26 years now. 27 years. Woo! The mean income for adults, I just Googled this and it was on some government website. They say for young adults, I don't know exactly what that means, 18 to 22 maybe? But anyway, it said young adults without a college degree, they make $22,900. Then there was a sample of 45 college graduates that found the mean starting salary to be $45,327. So that's obviously a lot better than making $22,900, but is 45 people enough to actually prove anything? And then according to the last census, the standard deviation would be 10,247 for college graduates. So there we go. Test the claim that the two groups make the same amount. Now notice this is something a little bit different because this is the first time I didn't say use 97%, use 98%. Well, that's actually pretty common. And when that happens, you use 95% as a default. So anytime it says test the claim and doesn't tell you what level of confidence to use, go ahead and use 95%. And also in here, this is the first time it didn't say test the claim that the mean equals such and such. But it's implied right here, test the claim that the mean for these people, college graduates, is the same as for these people, the non-college graduates. So this is our X bar, This is going to be the mu. So the claim is that the overall average, mu, equals $22,900. It's going to be a two-tailed test, which I forgot to write right here, but it's a two-tailed test. And as always, write down the sample information. And next, the picture is going to look like this. Since we're using two tails, and we've got alpha equal 0.05, then it's going to be 0.025 and 0.025. That is the most common z-value there is, 1.96. So that one I actually didn't even have to look up anymore. But if you look at the bottom right corner of table A2, it will show you common z-values, and 1.96 is one of them. Okay, so as I pointed out before, because the sigma is known, we're going to use, get back here, we're going to use the z-test. And so this is from the claim, our sample data, and then make it a two-tailed test and calculate. So the z turns out to be 14.6, which goes way, way, way past 1.96. So we way, way, way proved something. And what we proved is that we can reject H sub O. So this equals is rejected. The claim, that's also rejected. The claim is false. So for college graduates, the average is 45,000, way better than for non-college graduates. So that's just a lesson to you to hang in there, graduate from college. You're going to be making like almost twice as much. All right, until next time.